Assalamualaikum and welcome back, guys. So we are still in the same subtopic, which is on how to sketch a graph, and based on the graph you're going to identify whether the function is odd, even, or neither function. Okay, so as you refer to this example here, okay, you have three functions. So based on these three functions, you need to have two tables because you have a variable x here and also here. For the second function here, you know that this is a constant. So from negative pi over 2 to pi over 2, your fx is always pi. Okay, but for these two functions, if your value of x change, then your fx is also change. So that's why you need to have the table of coordinate, like we did in the previous example. Okay, so for the first table here, I am considering the first function where your x, I take two value of x is equals to negative pi, and the second one is x is equals to negative pi over 2, and I am considering the first function, which is pi over 2 minus x. So if you substitute value of x here, when your x is equals to negative pi over 2, then you will have 3 over 2 pi. The next one, when your x is equals to negative pi over 2, so pi over 2 minus pi over minus will you have plus. So you will have pi here. So therefore this is your first point and this is your second point. Okay. For the second function here, you don't need to do this table of coordinate because this is a constant. So now we are going to proceed with the third function. So I am considering these two values, which is x is equals to pi over 2 and another one is x is equals to pi. And my fx is equals to x plus pi over 2. So when I substitute x is equals to pi over 2, so pi over 2 plus pi over 2, then I have pi here. For the next one, when your x is equals to pi, so pi plus pi over 2, then you will have 3 over 2 pi. So therefore you will have another 2 point of coordinate. So now you are going to plot all these coordinates on your graph. Okay, so by considering this one, I already plot and I will just explain. Okay, so the first function here, as you can see, the first value is, for the first function, you have a point negative pi 3 over 2 pi, and another one is negative pi over 2 and pi. Okay, so when you take a look at this function, this graph here, so my first graph is negative pi, x is equals to negative pi, your fx is equals to 3 over 2 pi. So I have the first function here, this one. Okay, the second point is negative pi over 2 and pi. So negative pi over 2 pi. So this is my second point. So therefore I have to join these 2 points, then I will have the first graph. Okay, for the second function, when your x is between negative pi over 2 to pi over 2, your fx is equals to pi. So that's why I have a straight line here. Okay, when my x from negative pi over 2 to pi over 2, my fx is equals to pi. So I have a straight line. So this is my second function. Okay, for the third function, okay, the first value is pi over 2 and pi. So x is equals to pi over 2, your fx is equals to pi. So you will have this 1 point. Okay, and the last point is x is equals to pi and your fx is equals to 3 over 2 pi. So pi 3 over 2 pi is here. So you will have another function here. Okay, so you have one function, the second function, and the last function. You have three functions because your problem here, your fx, you have three functions. So now you are going to sketch from negative 3 pi to 3 pi. So the graph will repeat itself after this point. Okay, so this is your first function. Okay, and the range here is half. Okay, so now I stop until here, last one. Okay, so I have to start again with the first function here. So the range here is half, so from pi to 3 over 2 pi, so I will have another straight line here. Okay, and as you can see, it should be the same. Okay, because this one stop until pi, so the straight line is also until pi. Okay, so the next one is you have a straight line here. Okay, and this straight line is from negative 2 pi to negative pi over 2 to pi over 2, where this one is 1 and another one 2. Okay, so therefore here you stop until here, so this is your first function. So the second function will start here, so 1 and 2 stop here. Okay, and the last one is you have a function for the third function here, this line, so you will have this line. Okay, same goes for on your left hand side. So this is 1 2 3, so on your left hand side it should start with 3. So your function for number 3, you have this line. Okay, so that's why you have this line here. The next one is function number 2, so you will have a straight line here, and the last one is function number 1, where your function is in this way, the line is in this way, so that's why you have another one here. Okay, so as you can see, the graph is symmetrical about fx axis. Okay, this one is symmetrical about fx axis, so therefore this is an even function because this is symmetrical about fx axis. Okay, so for the next example, let's consider this problem. Okay, please do some correction in your notes because I forgot this modulus sign. Okay, so this one you have your fx is the modulus of x, so you need to have the table coordinate table first. So by considering your x is equals to negative 1 and another one your x is equals to 1. Okay, and so this is your x and your fx is equals to the modulus of x. So when you substitute negative 1, your fx is equals to modulus of x. So if your x is equals to negative 1, so you will have modulus of negative 1. So when you have this modulus sign, so therefore you will have a positive value which is equals to 1. Okay, so when your x is equals to 1, so you will have 1 here. So therefore the first point will be negative 1 and 1, and the second point will be 1 and 1. Okay, so in this case you just have one function here. Okay, sorry, this one is not 2 pi, this is only 2. Okay, because now your x, the range for x is 1 not pi. Okay, so you don't, please do the correction in your notes. Okay, so you're going to plot this one from negative 3 to 3. So therefore you will have this function. So this is your fx axis, sorry, your x axis, and this is your fx axis. So 1, 2, 3. So on your left hand side you have -1, -2, -3. Okay, so the first coordinate will be -1 and 1. So -1 and 1, so let's consider here. Okay, so the second coordinate will be 1 and 1. So if you don't know how to join these 2 points, either here or the straight line here, so you need to consider another point for x. So as you can see, from -1 to 1, you have x is equals to 0. Okay, so -1, 0, 1. So you already consider these 2 points. So now you are going to consider x is equals to 0. Why you need to consider x equals to 0? Because you don't know how to join these 2 points. Okay, few of you might do a straight line here, or few of you will from here to here first and next this point. Okay, so you don't know which one is the correct one, so that's why you need to take another value of x. So when your x is equals to 0, so for sure your fx is equals to 0. So you will have another coordinate which is 0, 0. So the coordinate 0, 0 will be here. Okay, so therefore we will have a straight this line, this one and this one. Okay, so without this point, some of you might have just give this straight line. Okay, so that's why you need this point. Okay, so if you don't know how to join the 2 points that you have, so you need to consider another point. Okay, so you were asked to sketch from -3 to 3. So this is your first. So you have the first, this one, and the second one. So you will have another one here. Sorry, one here and here. Okay, and for this side you will have down here and up here. So please do it correctly. Use your ruler. Okay. So as you can see here, this is symmetrical about fx. Okay, so therefore this is an even function. Why? Because symmetrical about fx exists. Okay, so the last example here, where you have your fx is equals to 2 and another one is fx is equals to 2x over pi. So you need a table of coordinate only for the second function here, because you have a variable x here. Okay, so you will have to consider your x is equals to 0 and your x is equals to pi, and your fx is equals to 2x over pi. So when your x is equals to 0, then you will have 0, and when your x is equals to pi, so 2 over pi multiplied by pi, then you will have 2 here. Okay, so therefore you will have a coordinate 0, 0, and another one is pi 0. Okay, so how to sketch this one? So here the range is from -3 pi. You were asked to sketch from -3 pi to 3 pi. Okay, so you will have pi, 2 pi, 3 pi. So this is for x. Negative pi, negative 2 pi, negative 3 pi. And for your fx here, I'm using 1 and 2 and 3. Why here I'm using 1 and 2 instead of pi and 2 pi? Because you have to consider your fx here, because now you have 2. Okay, so between negative pi to 0, your fx is equals to 2. Okay, so your first function from negative pi to 0, your fx is always equals to 2. So therefore you will have a straight line here. Okay, for the second function, so refer to this table of coordinates. So your first coordinate will be 0, 0, which is here, and the second one is pi 2, which is here. So therefore you will have a straight line. Okay, so you have two functions here, and the function repeats itself after this point. So this is the first one, and this is the second one. So therefore your next will be here. First one, and this one, the second one. Okay, for your left hand side, so start with the second one. So you will have a straight, you will have this line. Since you stop here, then you have to start the new one here. Okay, so this is number 2. So your first graph is a straight line here, so you will have another one here. Okay, so as you can see, this graph is not symmetrical either at origin or fx axis. So therefore this is a neither function, because it is not symmetrical about origin or fx axis. Okay, so we are done with how to sketch a graph. So in my next video I will teach you on how to find the Fourier series expansion based on your graph here. Okay, so you need to know how to sketch the graph, because based on your graph you will know either your function is odd, even, or neither function. And for each function that you have, for each type of function, there will be a different way on how to get your Fourier series expansion. Okay, so I shall see you in my next video for the last subtopic. Thank you. Wassalamualaikum.